Okay, so first of all, I will be opening the same GitHub PDF I created. So first of all, we will be learning about Git and GitHub. So how we will be using it throughout our project work, how we will be storing this. So today we will be learning about the version control systems, basic CIL commands, introduction to Git, how to install it, how to make an account on GitHub that you already guys have, I guess. So what is version control system? So suppose you are an astrophysicist, okay, you are actually. So you have a fetch file of galaxy and you have your pipeline, main.py, you have written the code to analyze something for that galaxy and you have some plots and then you have your research paper written in the LaTeX. Okay, so all of you know these are the things, but if you want to share this with your colleagues, the fellows, how would you share? The first thing is you can mail them, and if you want a long-term storage, you can upload that on a cloud platform of coders, programmers, astrophysicists, and researchers, that is GitHub. And you can make a track of your work for yourself uh, using the version control system. So we will look how. So version control system manages the entire process of the version as written here. It tracks the changes made, revert back the changes, and if you want, like you deleted the previous version of the code, you can just retrieve it back using the version control system. If you don't use the version control system, you might lose the previous process. So that's the benefits of the version control system. So first of all, we will be looking at some basic commands of the command line. The terminal, I will be using the Mac OS over here. You might have Windows or Linux, so it might get a bit different, but overall process will be same. So first of all, this is the GUI, graphical user interface, everyone knows, and this is the command line interface. We have this as CMD in Windows, Linux we have different, and we have a terminal in Mac. And these are some of the commands I will be showing how you can run this. So basically, first of all, I would like you to do it along with this whole process. Okay. So for example, I am here in this main root folder. So if I just click on PWD, it will show me whole path of my current folder, which is AstroDingra. Okay, so if I just want to open the desktop, we have some files here, of course, and if I just want to open this folder, we will use desktop, CD desktop. I hope you guys know this. This might be simple to you. Everyone knows this, but as a part of this course, I should tell you before we going to do some complex stuff, of course. So we opened the desktop folder. When I wrote CD desktop, it opened the desktop file. And now if I want to check what are the folders inside this or the files inside this, I will just write ls. Okay. So we have the index.html, we have archive, zip files and all that stuff. So if you want to clear all these things, you can just write clear and it will go away. Okay, you have a very clean thing here. I'll just turn off my video for good connection. Okay, so if you want to make a directory or make a file using command line, how you will do? You will write make for mk and dir for directory. Make dir and your file name. For example, uh, second underscore AGN school. So you see, this is a file already, not already, just created right now. When I wrote make dir, and if I want to go to this folder, I will write this thing, cd, the name of the folder. Okay. Sorry, I can't. So when I just, okay, okay. So if I want to create some file, like I have to write touch, then the file name. Okay, so it can be any file. It created this readme file. Okay, so readme usually open for me in the VS Code. So I'll just close this VS Code. This is my some code already I'm working on. So when I write touch and the file name, for example, I need a markdown file. So you can write markdown file. If you want some main.py file, okay, so you can just do like this. It will create that file. Okay. For now, I'll just delete this file. Okay. And then we have some more commands, like if we want to open this in VS Code, you have to write code and dot. This will specifically open this folder which we have been directed to earlier in the VS Code. However, we won't be using VS Code much in our whole program. We will be using the Jupyter Notebook. So if I press enter, so it opens this folder AGN, which don't have anything right now. So in the main VS Code. So I'll just quit this for now. And I just want to know for this time. So yeah, you can also remove this any file with by writing rm then file name. Okay, so this is the basic command, and I just want to know if you guys have already downloaded the Git and Jupyter notebook with you guys. Otherwise, I will skip it. If you have not downloaded it, I will just show you the process. Just write in the comments if you have all downloaded it earlier. If not, I'll just show you the process. Okay, so we have only one yes. Okay, so there is one person who have not downloaded the kit, so we'll show you. Okay, so anyway, I'll just show you how to download this. You have this link here in the PDF I just shared with you. So right now you will see this website here, which is of the Git. And if you have the Windows, you have this set of files based upon your requirement. You can download this and install this. And if you are on the Mac, you might have this thing here. You have to write brew install git. So before downloading the installing the git, you have to download the homebrew. Okay, so if you already have xcode in your Apple device, then it will work without installing the homebrew. So I have homebrew. So if I just write here like brew install git, it's already installed, but if there will be some upgrade version of git, it will install it again. Okay, so it started auto updating the homebrew, and a whole process will go on. So right now I have already installed. I just press Control C to stop this command. So this is how you can install. This is if you have Linux, and the same follows for the Linux. You have to open the terminal and write these commands based upon what extension you are following. Okay, so if you want some more developer stuff, you can go to GitHub and clone the repository and work with that. Okay, because it's open source. So this is how you will install. So if you write git space slash slash version, it will show you the current version of the git in your uh, this desktop or your PC. Okay, so first of all, when you will be using Git, it will ask you some username and password, which I will show you in the slides. So you have to write Git version, and for the first time you will be using it, you have to assign it. Otherwise, it will ask you, it will throw some error. So this is the process. After installing the Git, you have to write these two lines: Git config slash slash global username, and after username, give it some username, and after that, you have to do the same for the email, and you have to write your email. And if you want, you can initialize your Git repo, which we won't be doing right now. So this is the later on step. So you can skip this. This is how you will install Git. It's not a huge process. You have to just write these three lines to verify this. Okay. So okay, so I guess only Shazna Fatima is not have not downloaded the Git. So I hope that she is now clear with it, and other have already downloaded. So the workflow of Git is like you have the main directory. You are working on some in some folder, maybe on some research. Okay, so you have text files, you have Python pipelines and all that stuff in that folder. You want to make a different cloud. You have to save all that in the cloud on GitHub. So how will you do is you will first add using Git. You will add that folder to a staging area. How will you add? By writing git add and some other things, the file you want to include. In Git, remember, if you want to add whole folder, you have to write git add and then dot. If you want to open a whole folder, then you have to use a dot rather than typing a specific thing. And then we will be working on this, no worry. I'm just giving you an overview how the process works. We will be definitely working like on this using these codes. Okay. Then we have the stacking area, and where files are temporarily stored, and then we commit the file into the repository and we push it to the repository, which is either visible to public, or you can make a private repository to make only visible to you and your collaborators. Okay, so we have already also created a private repository for second AGN school, where I will be adding you as a collaborator, which only you can see. Okay, then you can see the status, which will show you in the checking area that which files are new, which file are old, and which are already which are edited or etc. And then we have this feature git add. As I discussed, you have to write the file name, or instead of file name you can press dot or type a dot. It will add all the files, existing files or new files in the staging area. And you can also unstag it using the reset dot if you by mistake added a wrong file or something. Okay, then you have to type a meaningful git commit, like it will show you. I'll just show you. However, we will working this throughout. I'm just explaining you so that you get an idea when we will be working on it. So I'll just open my GitHub. I hope you have all created the GitHub account. So this is my GitHub for now, and we were also working on some open source Python package for astronomy, astrophysics. It is for the galaxy morphology. So we are also writing a paper for it. So for example, I'll just show you how this message will show up. For example, I have just uploaded some files. Maybe in last like 8 months ago, I just uploaded some images in this directory. So then when I was committing that updates to the main folder or repository, I wrote this message, which is revert, acknowledge, and cite, where I have some added, maybe I have added some acknowledge or cite things. And this is the update init.py, where in this folder I have a init.py. So I updated the init.py and I wrote the message update init.py, that this file is updated. So this is a last commit message you can see here. Okay, so these are the messages you can write to make sure for you and your collaborators to let yourself know what you have done in the past. So basically, this should be a meaningful message so that everyone can understand, unless you don't want others to know. You have different things like branches also. Then you can merge these all things. We will be working on this. This is not that useful until we are doing some open source big project like Astropy. So they have different branches. So I will be discussing when we will be working on Astropy in our session. Okay, so right now I will skip this part. Okay, so we have some more things like git ignore. Git ignore is very important file. Sometimes you have to use some APIs to fetch out the data. AstroQuery is one of the renowned open source package to use to query the data. And sometimes HSC uses email and password. And if you want to make an autonomous process of a pipeline to fetch autonomously the data of stars, galaxies, etc., you might need your credentials. If you want to make a full-fledged website, a full-fledged pipeline which automatically fetch your password, you have to store a password and email at a secure way so that other one cannot access. It only works for you. So this is the file which we create dot get ignore, which includes the path of the things. For example, it includes the build folder. This includes the to do folder. This includes some exe file or password. So while uploading the stuff on the GitHub, it will not upload these things. So I'll show you how. So I'll just go to the main folder. I just wrote CD. When you wrote only CD, it comes to the main root folder. Uh, right now, you can see here. I'll just show you. I was working on one of the GitHub repo. So I'll just go to desktop, TextWolf. It's not there. Okay, so I just change. Yeah. So you see, it has redirected me to this folder. I'm inside this folder now. So when I will just write here, uh, wait a second. So you can use arrow to check your previous commands. Okay. So this command is definitely not correct right now. I have not added some messages or things. So when I will right now, it is also have some issues. I'll show you how. I'm telling you how to do it. So right now it is also showing you the version, the execution path, help, and you can take this. So these are all the commands you can use. Right now I'll just show you status of this thing. So when I wrote status, it show me these things. Okay, so these are some of the things. Yeah, this is exactly I wanted to show you. So I modified the get ignore where I added a local node file. Okay, so getignore has a node file. So this project is basically on Node.js. So I just not want all the modules of Node I installed to be go on the GitHub, which is basically useless. If anyone want to use it, will install it again. Okay, so I just don't want to make the repository very big. So I just added this in the git ignore and also modified some of the files you can see here. So this is all tracked files it is showing right now. So this is how you can uh, take a look of your workflow. Okay, then we have what is GitHub. Of course, all of you know it is a platform where you can store your files, you can share and collaborate with your mates. Maybe they are out of the countries, and for the collaboration, we need a cloud platform. So yeah, so this is git push. We will be using it git pull to and then we have the git clone to clone the repository, clone all the files. So these all we will be using when we will be working on our repo. Okay, so I will be like showing you how to use it. Okay, so there are some common terminology like fork. So for example, you want to I'll just show you a very good example. Okay, so there are four forks here. So four people has right now forked it and make some adjustment, try to do some adjustment in the main code of this uh, open source Python package for galaxy prediction. Okay, galaxy morphology prediction. So if you want to contribute in an open source project, for example, we have Astropy. Okay, so I'll just open this. We have this Astropy here. So if I go to the main repo, Astropy repo, which have all the features, right now I guess 7.1 version I think is now released. So these are 2K folks. Okay, so 2,000 people have tried to contribute it. So you can't directly edit the files basically. So if you go to astropy.constant, there are different files, Python packages. If you want to edit this, you have to fork it first. Okay, so even if I just try to edit it. Okay, so because I am a contributor, I can edit it. So as you know, I was contributing in some of the Python packages earlier. So I can edit it. I have access. Maybe you might also have access, but if you want to edit it and commit changes, it will directly fork to your new repo. So it's also showing if you it will create a new branch as js/astropy. Okay, so I'll just control Z it, and yeah, I don't want any changes right now here. So this is how it works. So you have to fork the project. Wait a second, guys. Just a second. Hello. So yeah, I'm audible. So actually that repo is private right now. I will add you as a collaborator. It will show you up. It is right now private. So this, I think this Glamo website, this repo will be visible to all, of course, because it's not private. So to contribute to some project, you have to first fork it, and then you have to edit the code. You in whichever issue is there, you have to correct it, and you have to give a pull request. There is something called pull request. You will ask the main coordinator to check your code, and if it is correct, then it will be merged. Merged means you are now a contributor, and your code is merged in the main code of Astropy or open source project, and it will be used in the further process. Okay, so there are some issues here. You can contribute. There are many issues and or bugs there in the Astropy package. You can try to solve this. Okay, so there are already pull requests of the problems being solved. Some of them are open right now. You can there are some of draft, and some of them are already closed. Okay, already fixed. So this is how basically things work if you want to do some open source contribution. So this is the whole workflow. I'll just close this right now. Okay. So now we will be working on Python. Okay, so we will be learning the basic Python today. We will be learning variables, loops, slicing, and functions. And I know we have NumPy also in today's session, but I want to do NumPy, Pandas, and Matplotlib together in tomorrow's session so that we can get a good mind structure, mind flow of how the things work, because we will be mostly using NumPy, Pandas, AstroPy, Matplotlib together in our workflow. Okay, so basically now I will just open my terminal. For example, I want to store all the notebooks of Jupyter. So before that, I just want to ask if you have already installed Jupyter Notebook or not. So if you have not installed it, you can go to the project Jupyter. It's also open source. You can install it like this. So I'll just share it. Also, you can do one thing if you want. You can also install it through Anaconda. Okay, but it's a very big package. It includes many things. So yeah, so I'll just first go to my directory, main directory, second AGN. Oh, second. Okay. Uh, okay, so there is an error because I have to write desktop first because it's on desktop. So yeah, right now it is directed. Now I will write Jupyter notebook, just Jupyter notebook for this directory because I want the things to be open only in this folder. So now Jupyter notebook will execute all in this folder. So it will take some time, like few seconds, I guess it should take, and it will open in your browser. I don't know why it's taking time today, but no worries. Okay, so it's executed, it's opened. So I just want, I have this curiosity to tell you how the Python notebook works. So this is basically work on WebAssembly. There is something called WebAssembly, which is a mixture of a desktop software and a website. So it basically uses two things: website format also and a exe or dmg package folder. So it is basically a software for your PC, but it works on website. So this is something called WebAssembly. Okay, so yeah. So this will be empty. I want you also to create some specific folder for this process, and I'll just open. I've been working on Julia also in Jupyter Notebook. So you are seeing these three, and I have a separate Glamo uh, kernel for my workflow of Glamo, but I will open the Glamo folder because I will open the notebook, create the notebook through Glamo kernel because I have already installed many packages through it. So I just created the file here, you see, and you will see this type of thing here. Okay. First of all, you can go to settings and you can change the theme light, dark, or dark high contrast. So I like this one for now. So I will keep it like this. So also you can change your name, like let's say day underscore one. Okay, day underscore one. So the task today is, so there is something called markdown. I hope you guys know, but if you don't know, uh, Markdown do not execute your code. Okay, so first day of AGN school. Okay, when I execute it, it will show something like this. Okay, and I'll just copy it. When I just write these two hashtags, and then I write three hashtags, and then I write four hashtags. Wait a second. Let's just copy it again. And then I will write five hashtags, and then I'll write six hashtags. You will see the difference. So basically, it is working like this: bigger, small, small, smaller font. Okay, so this works like this. If I write five hashtags, oh sorry, seven hashtags, it actually don't work. So it works till six. Okay, so if you want to write something bold, okay, hi, you have to use a bit of HTML. Okay, so it's bold now. Okay, if you want also to it to be italic, this is actually HTML code, not markdown. Okay, so it's italic now. Okay, so this is how the things work. If you want to write like some formulas or something, you have different methods. Okay, so that I will be showing you when we will be doing the question thing. Okay, so right now, first code we have to write hello universe. Okay, so when you have to ask the computer to speak something in Python, to revert something in Python, you have to print it. Okay, so you have to write first print, and then you have to write this brackets, and then you have to write parentheses, and then you have to write hello world. Okay, so I'll just press shift enter. I just click the shift and return on Mac and shift or enter together to print it. Okay, so it will work like this. So we also have some more things here. Double parenthesis is very much used because if we have to write, it's good. So I have used a single parenthesis here, so it will execute fine. But you can also print this thing with the single parenthesis, but unless it has one more parenthesis here, it will create an error because the parenthesis ended with these things. So they work as a couple thing. So if it is started, it had to be end. So if you want to print it like this, you have to make it in couple. So that's why we use. I'll just leave it here. Uh, that's why we have to use it like this. Hello, hello's universe. Okay, it doesn't make any sense, but yeah, just to show. Okay. So this is how it works. Also, if you want to create some multi-line comment, you have to write it like with three parentheses. Okay. So twinkle, twinkle, little star. Okay, so it will print like this: twinkle, twinkle, little star. Okay. So we have one more thing. I don't want this. I don't want error also. So what I will just do is I'll just write this thing and make it in one line. Okay, so what this made is, so I'll just reduce the gap. So by writing slash n, it just moves the rest of the part of the line to the next line. Okay, rest of the sentence to the next line. So there are some more things. Okay, so basically this is showing like this, but it's actually a gap. When you write this thing, or also I guess T, yeah. So basically T gives you a much larger gap, okay, between some two things. Okay, so for example, I just do it like this, so it give a single gap, okay, like this. So this is how these things work. You have this thing. Then we have a comment. Comment is something which is not executed, just for the sake that other people should know what's this function or this code do. So this is a comment, single line. This is a single line comment. Okay, when I executed this, it prints nothing because it's not it's executed, but it doesn't include any code. Okay, so this is a multi-line comment. So when you have to write the comment, you can use three parentheses also without using these print and all that stuff. This was also this only work on VS Code, not on the Jupyter notebook. So we prefer this thing. Okay, so basically, Jupyter Notebook has a thing that it evaluate without print also. If you write like this, hello world, it will print it actually. It will print it. Okay, so this is, you can say, a feature or something for Jupyter Notebook. But when you do the same thing on terminal, for example, I'll just open a new terminal. I'll just open this new terminal and I'll just write Python here. It will just open for me as a Python. If I just write it like this, it will work here also, I guess. So it work here also. But if I do it in the VS Code, it won't work. Okay. So in Python 3, these things works very fine. So instead of like writing a multi-line comment like this, uh, it execute it as a code. Okay, multi-line code. Okay, a sentence, print sentence. Okay, so you can just go like this. This is the second comment, and you can like this. This is our third comment. Okay, so this is how it works. Okay, so I hope this is understand and very understandable and very easy for now. So now we will be moving on variables. Okay, data types and variables. Okay, I will be sharing a lot of things, a lot of PDFs with you. You have to just go through that PDF if you want. A whole bunch of notes. I have a lot of material for you because in 2 hours we won't be covering every single detail because we want to focus more on astrophysics, computational astrophysics rather than coding. Okay, so we want coding to help us, but we want astrophysics as our first priority. Okay, so I will be sharing some of the code also with you guys. Okay, so you have to check it. So I hope every one of you is on Slack so that no one miss the any information. However, I will share you on mail also. Okay. So do you have any? Is it is Google? Yeah, Google Collab is fine actually. Yeah, it's fine until you do machine learning or deep learning stuff. Glamo, our Python package was a deep learning, so we used Kaggle notebook for it to get our GPU from Kaggles. But until or unless you are not making use of GPU or deep learning or machine learning, Google Colab, Jupyter Notebook, and Kaggles are same stuff, so you can work on it. But the thing is, this is much good, like for me, as my opinion, like it feels good. Okay. Uh, Now we will be working on data types. So I'll just put a heading data types. Okay, so when I will execute this code, this is a comment, this is not a heading. To make it comment, I have to like press escape. Escape will come out of this cell, and when I will press M and shift enter, I press the M, it make the cell as a markdown, and when I will press shift enter, it will execute the markdown. Okay, now these are some examples of the data type. Okay, so I'll just writing something. So it's easy to understand, I guess. Okay, one thing more. I want you to go to settings and click on this auto save document and auto close the bracket. So you don't have to write a bracket, close and opening bracket one by one. It will make it into a pair. Also the parentheses. So coming back to this data type, then we have this. Okay, so when I will execute this, this will not print anything. Okay, so this is executed because I have not commanded anything to print it. Okay, so it will not print anything. So x is equal to 1. This is actually a variable. X is a variable, y is a variable, z is a variable, w is a variable. It is actually some unknown thing which we have made it specific by assigning some value to it. Okay, so variable can be anything. So as the name suggests, variable can vary. Okay, so but right now we have defined a variable as 1, x as a 1, y as j string, and z as 11 dot and then we have W as true. Okay, so we have this true and false. So this is the integer, this is a string. When you have to write a string, you have to write in the parentheses, and then we have a decimal value which is known as float in the Python language. Then we have true or false values which is not as booleans. Okay, so true and false should have the T as capital and F as a capital. If you try to write this, it will throw an error because true is not defined. It always follows the capital T and capital F, so it executed. If you try to print a value of x, so you see, first I write x with parentheses, then I write x normally. So when I write x with parentheses, it just print the word x. When I write print x without parentheses, it give me the value of x as an output. Okay, so this is how the things work to print the value of the variable. We use it like this without parentheses, and to print something as a string. Okay, so if I just print xw, it will give me an error because xw will be considered as a new variable which we have not defined it. But if I print something like x plus z, it will actually sum up the values. So how the things work here is, because these both are similar things, integer is also a float. Okay, so I just want to write here something before this. Integer is a float, but float is not an integer. Plus, below command converts the integer into the decimal as 1.0, and then do addition. Okay, so this is how the things work. Okay, so this is basically the use of commands. When you use a command, it let us or others know what the below functions do. Okay, but if I try to do something like this, y plus w, oh, w, it will throw an error because it says concatenation of string and booleans can't do. Which means basically this is a different data type, which this is a different data type. We can't convert the two things into a single stuff. We can convert integer into float, but we can't convert a string into float or a boolean type. Okay, so this won't be working. So we will have to normally do something like this. W if you want to print. Okay, so I want a line. Let's say 9.1, and okay, and yeah, that's good. So I want to make a sentence which include different variable values. Okay, so I want to print some a sentence which include my name, my CGPA, and CGPA to be true. Okay, so what I will do is I will write F in front of the parenthesis, and then I will do name is Y, CGPA is Z, uh, pass is equal to W. When I just printed it, printed the values of the variables like this. Okay, so we have F, then we have the parentheses, double parentheses, then we have name, then we have colons, then we have the curly brackets, then we have the Y, the value to be printed, name JS Dingra CGP 11.2. Of course, we have not executed this because it's showing yellow. If I execute this and run it again, it shows 9.1, pass through. Okay, so this is how the things work. Okay, so anyone have any doubts till now? It's very simple right now, I guess, because most of you are like MSc and PhD, and I guess you have been working on this. Okay, yeah. So now we will be working on something called input and output functions, and then we will be going to slicing, list, slicing, indexing. List slicing indexing is very important for astrophysics because we have fetch file, we have tables in it, and those tables include different index, and different index have some datas, and when we have to fetch some data from that particular table and that particular index, we use indexing. Okay, so we will be seeing how we do that. Okay, so first we will be creating a markdown. So there is something called if and else thing also. Controlled classes of Python. Controlled classes of Python. Okay. So after that we will also be doing this if we have time. Yes, we have a lot of time. So let's say we define a variable name and we write input and ask what's okay your name, and then we print n so that it should ask in the next line. Okay, so when I will write print f hello then name. So what this function do, what this code do, it asks the user for his or her name by using input command input function. Then it greets the user by saying hello name. Okay, so basically when I run this command, you see there is an asterisk here, which is showing the kernel is still running. Okay, so basically this is the kernel. If you have a long code like Astro query, you have run a very long query and it's taking a very long time, and you just get to know that your query was wrong. That's why it's taking a long time. You can just interrupt the kernel here and everything will stop, and you have to restart the kernel again so that you can work finally well. So we will be using it in the case of while loops. So while loops are something which are conditional loops, conditional functions which work. So when we provide some condition, it will run until that condition is satisfied. Okay, so we will be making the use of interrupt kernel soon in this lecture only. And this is the kernel name you are using. You can change the kernel from here. I will not change right now. And this white dot is showing that kernel is busy. When you hover on it, it shows the kernel is busy. Executed cell 0 out of 1. Time elapsed that it has been 73 seconds till now. That kernel is busy. Okay, so 0 out of 1 cell is executed properly. Okay, so when this circle is like blank, not colored, okay, so it means the kernel is free. Okay, so right now it says what's your name. When I like Jashanpreet and I press enter, it says hello Jashanpreet. Okay, so this is how this function works. That's all we want to learn about input and output functions because we don't have any use of input and output function in astronomy, maybe rarely, but not in my work right now. Till now, I have not made any use of our input and output function. Okay, so then we have loops. Okay, very important thing. Loops are very complex things and very useful things. Okay, so so there are something called list also. We will be covering list also here. However, we will be covering the concept of list, tuples, dictionaries, that all things in NumPy series. Okay, tomorrow in detail. However, I will give you overview today only. Okay, so loops. So there are two type of loops. While loop, we have while loop and for loop. Okay. So for loop is a control loop. It is very easy to use. It is used when we have a specific range of data, and while loop is used when we have some condition. Okay, most of the time we use this for loop. So I'll just make it marked now. I'll just make it marked down as double hashtags. Now I'll create a list. List is created with the variable assigned, for example, planets, and then we have this bracket, square brackets, and then we have different values separated by commas in it. Okay, and we have to write the values in either parentheses or just like this only. Like we have Mercury. Okay, Mercury. Then we have our Venus. Then we have our Earth. Okay, so then I want to write 1. I want to write 2.0. Then I want to write true. Okay, so the list can contain. Okay, so I'll just write here as a comment. List is a thing in Python in which we can store different data types at once. Okay, so when I just try to print planets, of course it will print the planet. But when I will write this, it will print the whole list. Now, what if I want to print a mixture of these? Just for the sake of revision, I will use F, then parentheses, then I will write first planet near to sun is is planet. Okay, so it's complex. It's complex. I know it's complex. I just merged many things in one line. And what's this zero doing here? Okay, so I don't know why I did this. I wanted to do this earlier in indexing stuff. So I'll just give you an overview, but I will show you in detail in the next part. So first planet near to sun is planet, and then we have brackets, then we have zero. So it's basically the value assigned to these different data types. So in Python, the counting starts from 0. Okay, so 0, 1, 2, 3, 4, 5. So 0, the place value for Mercury is 0, the place value for the Venus is 1, the place value for the Earth is 2, the place value for 1 is 3, and place value for 2.0 is 4, and place value for true is 5. Okay, so when I just write after planet, the bracket 0, it print the name of that value at the 0 index. Okay, at the 0 place value. However, we will be learning in the uh, indexing, you can skip this part. Okay, so now let's make use of the for loop to print the all values. What I will do is I'll just create, I'll just name it as list 1, then I'll print this list 1, and then I also name it as list 1, and I now create a list of planets which is like Mercury, Venus, Earth. Okay, that's it. I can't write all the planets name right now, it will be time consuming. Okay, so we have three examples. Let's make a loop to print all the values. Okay, so let's create a for loop basically. So for x in planets, then column print of planet name x, and then the next line. Okay, before executing this, I just want to tell you what I just did. For x in planets, for x means the elements in the planet list. Okay, so I'll just do it. I'll just execute this and I'll make a new thing. So I just made a new cell. I just made this new list planets, and I wrote for x in planets. X means elements in planets. Okay, for example, I write A in planets. It works. Okay, so I write planets, planet in planets. Okay, not planets in planets. Okay, so this will not be printing anything. Okay, so also we have to print planets. Okay, so you can write same thing. I just discovered it now. I don't know. My mentor said this. You don't have to write the same name. Okay, so you can write this, but you can write anything here. Basically, for x in planets is more reliable because it doesn't make any confusion. Or I in planets, it just defined that I or x or any name you write here is the elements in that particular list. Okay, so to print that list, you have to write the particular value here. Like then I wrote this column here and then print enter, and it automatically created a tab space, and then I wrote print bracket, then f parenthesis planet name, then curly bracket I. So when I print this, it will show you line by line planet name Mercury. Then due to slash n, it create a vertical space and leave a line, and then write the next planet, next planet, next planet. Okay, so this is how the for loop happen. So here, why this happen? Why we have not used a while loop or something other method? Because for loop is on works when we have a range or we have a data set. Okay, we have a specific defined values we want to print. So we have these specific defined values, a range of values. Okay, for example, we want to print for x in range. Range is also one of the functions like input. It will print all the values from 1 to 10 without writing 10. Okay, so 1 to 9 it will print all. So if I just write print x, it will print 1 2 3 4 5 6 7 8 9. So if you want also to print 10, you have to write 1 n plus 1 basically, so that you can get the value of n. Okay, so this is by default. Okay, so I can't do it anything in it. So for x in the range 1 to 10, print x. So x is element in this range 1 to 10. So this is how for loop works. However, we will be looking in detail when we will having a use case of for loops in our data. Okay, so when we will be fetching data of AGNs or other galaxies, so we will be doing that. So till now, any query, any questions? Then we will move forward to while loop and then if else statements and then finally functions. Okay, so yeah. So let's do while loop. Also, at the end of this session, we will be using Git to push this to our GitHub repository. Okay. So there is one thing for the while loop. Let's say we want to create a Python command where we instruct our PC or our program or our computer, whatever we say, to count the values before some specific number. Okay, so you have to print all the values, all the numbers before that specific number. But here we don't have a range. We don't use for we don't want to use for loop, but we want to use some other method. So what we will do is we will use while loop. While, let's say you have to count before 20, okay, or till 10 to 20, okay, it's the same thing. Okay, count before is equal to 20, which means you have to include 20 also. Okay, so print then f. I recommend you to use f parenthesis every time to make your code look beautiful. Okay, so it's not that hectic, but it shows some skill when you showcase your work to professor, even if he don't know about it. Okay, so count and then count this one. So basically, this do is, so it will check until 20 comes, and it will what it will do is it will print count and then the number count till like 1 2 3 4 5, and every time he prints that count, for example the count is 1, the next count will be count plus is equals to 1. Means for example the number is 1, then it will next time it will print 1 plus 1 2. Okay, so this is how it works. So when I will like do it like this and press shift enter, it won't work. Okay, so it will give an error because we have not defined anything count. Okay, so we have to define count starts from 0. You have to define it before while applying the while loop. Then initially the count is 0, you have to start from the 0. Okay, the sum is 0. Okay, so when I just print enter, it just print 0 to 20. When I will remove this is equal to sign 20, it will print till 19. Okay, so there is some more situations of while loop when it never stop printing. If I remove this condition, because this this is a condition where the while loop have to stop until 20 comes. When it see the value 20 and it confirm in the code that it is equal to 20, it will stop printing count after that. But if what if I remove this and print it? Okay, so nothing happens because I have not defined anything here, no condition. But what if I do it like greater than equal to 1? It will be always greater than equal to 1. Okay, so okay, let's say I'll just write here 0. If the value is greater than 0, it will print it. Okay, so it will like go and print it every time, like infinity times. Okay, so uh wait a second, I'll just try to define some specific value. For example, okay, so it's not showing here, but it's running without an error. Wait a second. Uh, okay, so I just wrote it as 0 is equal to count is equal to 1 while it's greater than 0, and then I just okay. What if I just try this thing? Let's say 0 while true. Okay. So I just messed up here. What I did earlier was I just defined it some condition already. Uh, if I just write true here, it will say everything is true. You have to just print it. Okay. So now my system will gonna hang soon because it's anomalously and like randomly printing all the things in line like again and again. So of course you can see some lag here. So now what I have to do is I have to stop the kernel either from this button, interrupt the button, or kernel. When I just wrote while true, it says all conditions are true. You don't have to stop in any condition. Everything is true. You have to just print it till infinity, till nothing. Like you have to print it as long as it goes, as long as the condition is true. Okay, and so it prints anomalously. Okay. Okay, so I'll just click on it. Okay, so I need to stop this. Okay. Control. Oh. Wait a second. Oh. Okay, so it just created some chaos because I just pressed Command Q. So I will just share the screen again. So that's why said that while loop is very rarely used when you want to create some chaos, you can say. So I'll just okay. So it just automatically, because the autosave was on, it automatically give me what I just opened. So I just write here execute at your own risk. Okay. Oh shit. I just read it. Okay. Okay. I just executed it again. I'll just again write it is equals to 0, and then I'll while count is less than equal to 20, this is a condition print f count is equals to count. Oh, wait a second, and then L. Okay, so count is equals to +1. Okay, so it will work. I'll just restart the kernel once again because I stopped it in between. Okay, so it printed it like that. Okay, so this is how it works. Or one thing more, I'll do it here. I'll just also do true here. True for infinite series. Okay, execute at your own risk. And I'll not execute it, I'll just add a separate cell, and also I'll just do it as a row so that I'll just show it like a cell and not execute. Now, since we are done with the chaos stuff, now I will like to move forward for the if-else statements. If elif and else statements. Okay, so if else and elif statements are very useful. Okay, so these are the conditional statements. So I'll just show you one of the very simple example. First, let's say you have a is equal to 1. Okay, so I'll just zoom it for you. And then we have b is equals to 1, b is equal to 2. If now how to write the if statement? If a plus b is equals to when you have to confirm that it must be equal to that specific value, and then you have to write double equal to sign in Python, and if it is equal to 3, print true. Elif means if you have some other condition along with the if condition. Okay, a minus b is equals to minus 1, which is also true. Print yes. Okay, otherwise else then column print go away. So basically it was a true statement. It print true. Basically, why not printed yes? Because it was also like a minus b is minus 1. It must print yes. But why didn't it do that? So basically it goes line by line. So if the first statement is true, other will not work, and it will stop and it will print whatever is commanded here. But if else wrong, let's say I printed 2, a plus b is not true, not 2, we know, so it will go to elif, so it will print yes. Okay, so this is how it works. Okay, so one more thing I just want to tell you, uh, if you want to print both true and both yes, then you have to do one thing. You have to write if both times, because if is given the first priority, alif is given to the second priority, and else is given the third priority, last priority. Okay, so it will what it will do. Okay, so I'll just write here. It will print true as well as yes. Okay, so this is how it works. So this is all about the if else statement. However, we will be going in detail for if and else statement soon. Okay. Now the two most important things: list, indexing, and slicing, and then we have functions. These are most of the things and key takeaway of these lectures. Even if you forget all these things, no worries. But if you forget how to do indexing, slicing, and how to create a function, that will create some problem. Okay. So now we will be moving forward for list plus slicing plus indexing. Okay, the final showdown for today's lecture series. So planets is equals to, again we define some planets, but now we will be defining the gaseous giants. Saturn. Oh, sorry, Saturn. Then we have Neptune. Pardon me if I am wrong, because I know Uranus. Oh, yes, I got everything. Sorry, Pluto, you are not gaseous, but I love you. Okay. I don't know. why I write Pluto here. So also I think the series is wrong. Okay, so now we will be focusing on indexing. Indexing. So indexing is basically, as I told you earlier, it is a place value. Every value or data type in the list is given some place values, and indexing is basically that place value. Index is that place value, and indexing is a method to use that index value to fetch that value at that place value. Okay, so I know it's complex. I'll just show you how. So okay, so planets. Then when I will print 0, it will print Jupiter. Okay, pardon me, guys. Okay, so it will print Jupiter because at the value it come. So I'll just show you counting or indexing in Python starts from 0, 1, 2, 3, or -1, -2, -3. So when I will print something like -1, okay, so okay, planets, okay. When I will print -1, it will print me the last element. Okay, so if you don't know, if you have a lot of data, you know what, you don't know what's the value at the end, but you want to know it. How will you do? You will just print that index with -1, it will print the last value. Okay, if you print 0, it will print the first value. Okay, first value, last value. Okay, then we have this thing done. If I just do it like, it will show Saturn because 0, 1, 2, 3, 4, -1, -2, -3, -4, -5. Okay, so these are like this. Excuse me. Now, there is a very simple rule of slicing. So we will do slicing here. So this is how the index is simple, but slicing make use of indexing to work. Okay, so slicing has a very basic rule, which is start. So in the brackets, the square bracket, we have to keep in mind, we have to start, we have to stop, we have to skip. Triple S. Okay, so what we have to do is, like, for example, uh, we want to print not all these planets, but some of the part of the list. So we use slicing. As the name suggests, we will slice the list into some part to fetch that particular area. Okay, so planets, and I will start from 0 only, 0 index value. I want Jupiter till Uranus. Okay, then I'll put this column here, then I will stop 0, 1, 2. So in Python, as I told you, if I just write 2, this will print till Saturn, not Uranus. To print Uranus, I have to write a value plus 1. Okay, 0, 1, 2, 2 plus 1, 3. So I have to write 3. If I just print this, it will print Jupiter, Saturn, Uranus. Okay, now if you don't write this, it won't skip anything value. Skip value. If I just write 1 here and then print it, it won't work. When I write 2 here, it works because it prints the every second value. Okay, so how does the skip work? It will consider Jupiter as the first value and it will skip the second value after it, and then we have stop. If what I will do is try one by one. I'll just, if you want to do it Okay, so what we can do is, let's create a markdown separately and then move this forward in a different cell. Okay, okay. So this print like this. If you go it like this, what it will do is it will start from 0, it will end till whole list, and it will skip every second value. So first value was this. In slicing, the first value is this. It's not the 0th value, it's only for indexing. So it's the first value, it will skip the second value, then it is the first value, it will skip the second value. Okay, so this is how it works. Maybe confused. I'll repeat. This will be the first value while it's skipping. This will be second value, it has to skip. Then this will be again the first value, this will be the second value to skip. If I'll just do it, if I'll just print this, it will print the same, because even if you write 0 or not, it will consider as 0. If I just write it here 2, it will start from the second index 0, 1, 2. It will start from the Uranus, and it will consider Uranus as 1, and it will skip the second value as Neptune, and it will print Pluto. So this is how it works. So this is how you have to play around with the actual data. Once we have the Fritz file in our hand, I will we will do some practice how it works in our main application part of our school. Right now we know we want to just know the basics how it works to get this wooden sword into a actual sword. So I just, if you want to slice this Jupiter also. Okay, if you want to slice the word Jupiter into a different part also. So I'll just define a name query, and then I have defined it as a variable, and I define it as 0, and I'll print it. It will print Jupiter because it is defined as the first value. Or even if I'll do it like this also, not by just writing print, it will print Jupiter. It's just these things. It doesn't matter. Okay, now you have to apply slicing on quitting. So let's say you have to skip every two part and you have to print this. This is how it works. So this is slicing under slicing, nested slicing. Okay, you can say I just gave it name right now. So this is how the slicing work, and it's very important in astrophysics for data analysis. Okay, so it's very important. So now we will move forward with the functions, last part of our session. Wow, we completed on time actually. We have 15 minutes left. So yeah, I think we completed on time. I was not thinking we will be completing because today was also a short orientation. Yeah, okay. So yeah, hashtag functions. Functions are very important. So I'll give you a task. I'll give you some assignment, a small assignment, very small assignment, hardly take 5 minutes to complete. I will give you a problem. You have to create a function to solve it. Okay. So before that, we have to learn functions. Okay. So functions start with this def. Okay. So define function. De means define, and f means function. Okay, so it means define function, and then you have to write a function name, a very simple function. Let's say greet. We have to define a function where we will ask for the username and greet the user. Okay, so what is the difference between then what is the difference between what we did here? This was also a function. It is not a function, it is just a program. This is just a code, and we have to write this again and again for compiling it. We have to write this again to execute it. But function are very like general thing. You have to just call that function name, just the greet part, rather writing the whole code to run that function. Okay, so it is basically a package of a big code. So you have to just call this name greet to to do all the coding part, whole big things. Not big things for now, but maybe in the future we will when we will be creating a big functions for BPT diagrams, of course. So there are BPT diagrams which help us to separate AGNs from the star forming galaxies and also cipher galaxies from the liner galaxies. Okay, so let's say we have to greet the name and then we have to, of course, we have to print this column and then we will print something like hello, then of course name. Now this is the function. Okay, so now this is created. I will make an input where input as name. Of course, we have to give some function name. So name will be is equal to some input. It will be asking from the user what's your name, and now greet name. So basically what I have done is I have first defined a function name as greet with a parameter. So basically this is a parameter. This is a parameter and then it will print f hello that parameter. Okay. So in a function we don't call it element, we call it a parameter. For example, we have a Gaussian function. Gaussian function, let's say distribution formula. Okay, so you see this Gaussian formula here. So this is basically bell curve or normal distribution everyone has studied in high schools also, I guess. So this is the function. These are different parameters x, mu, and sigma. So x is a one parameter, mu is a one parameter, sigma is a one parameter. So while creating a Gaussian function, we have to define this x, mu, and sigma in this part here, in this bracket here, maybe name, name 2, name 3, maybe sigma or something, and we definitely have to use it. If we want to be using where there is no name, it will throw an error because we have to define the things, define the parameters we're gonna use. Right now we wanna use only name, so we will only define the name here. So now I'll just run this and ask for my name. I'll just write Jashanpreet. When I press enter, it will say hello Jashanpreet because we have called greet name. So now, if I just package it out into a Python package, which is useless actually. So this is how actually the Python packages work. So Astropy contains bunch of codes, and those codes contain bunch of functions. And when I call, for example, Astropy, like import Astropy from astropy.io, let's say, this is just an example if you don't know. Astropy.example import fits. When I just do this, and it import that module of Astropy, which is known as fits. Okay, and when I will do fits.open and then fits file, some fits file, it will actually open that fits file. But the code behind this whole function, this open function, the fits function, this module is a long bunch of defined code parameters and functions, which basically help us to just write it as it fits these four words to use whole bunch of code for just opening that one file. If there is no fits module in AstroPy, we have to write a whole bunch of code to open that file, the fits file. So this is how the basic fundamentals of function works. To when we have a large chunk of data, a large chunk of pipelines, we package them into a function to just call it every time with the small name rather than writing a whole bunch of code again and again. Okay, so this is how it works. So I have a small task for you. So the thing is I can do it here also. So I will do in tomorrow's lecture. So the task is create a function for calculating redshift of a galaxy, which ask, okay, I'll just create the markdown first. Okay, so I'll just write it here in bold. Hey, wait, what's happening? Wait a second. Just a second. Okay, so it was a glitch. Okay, so it was a glitch. Create a function for calculating the redshift of a galaxy. Which galaxy? Okay, so we'll define it later. For a galaxy, yes. Let's take a real data. Okay, so we have. So this is a very bad thing of SDSS because they don't have a proper SU. Okay, so this is a very old. Okay, so this is data release 4. We have 18 now. I know this. So okay, let's open that only. Earlier they used to like open have this. Okay, so we have. Wait a second. I just want a real verification. Okay, so every time I just lost finding these things. You mean navigator? So I'll just pin that this time. Okay. Where is the file? Where is the navigator? There was a new website actually. This is the old website, I guess. Okay, so for the time, let me give the last try. Navigator. It was starting on the link maybe. Um, it's still. They just changed it. I'll just try this one time. Okay, I'll just find it out. I'll just find it out because I just opened it. I just deleted all the pin comments, pin tabs there. So calculate a function. Create a function for calculating the redshift of the galaxy. Uh, yeah, using the redshift formula and asking the users so the observed observed wavelength from the spectrum. Okay, so this is the task. I'll just make it big also. Okay, so the task is to create a function which calculates the redshift of the galaxy using the redshift formula and asking the users the observed wavelength from the spectrum. The thing is, I have not provided you the redshift formula because I will be solving this in class next lecture. And also the second thing is tomorrow before going ahead, I will be showing you the real spectrum of the galaxy, and from the spectrum we will also fetch that uh, the wavelength thing. Also, if you need any help, more detailed code of how to fetch or how to get the observed wavelength, you can use the my pipeline we created at Ayuka. So it's here on my like main profile page. I've built this. So there is something called velocity dispersion fit. So it's actually for calculating the velocity dispersion of the galaxy using the spectrum by fitting it, but it also calculates the redshift. Okay, so it also gives you the like the observed wavelength if you just want to test it out. Yeah, this is whole manual how to use it. So you have to like download whole this code for the purpose, and this is the report. So this you can use, but try not to use these things. Try to use what we learned today. Just functions, just functions. Okay, just functions, input functions, and yeah, that's all. And choose one galaxy from SPSS. I'll just share the link with you. Choose any galaxy. Okay. And by choosing that galaxy, you have to verify that your results are correct for that redshift or not. Okay. So that's all. Uh, I'll just end up the recording here, and for discussion, I'm open. Okay, so where is the software?